Where does a container image actually live before you deploy it? Not on the laptop that built it, not inside the running container. It lives in a registry, a specialized store that teams use to publish images, pull them, and keep versions straight. Think of it as a warehouse with a catalog. The warehouse holds the boxes, the catalog tells you which box is which version. If you skip this piece, every machine has to rebuild the same app from scratch, and nobody can trust they are running the same thing. Here's the part that matters. Once you understand registries, Docker stops feeling like a local trick and starts feeling like a delivery system. Start with the image itself, because the registry only makes sense if you know what it stores. A Docker image is a read-only snapshot. It packs application code, libraries, dependencies, tools, and the instructions needed to create a container. It is a blueprint, not a running process. The container is the living instance you start from that blueprint. Change the running container and you have not changed the image. That is why images can be copied, tagged, and shared without dragging a whole machine along. One concrete analogy: the image is a sealed recipe card. The container is tonight's meal. You can cook the recipe 100 times in 100 kitchens and still be following the same card. A Docker registry is centralized, scalable storage and distribution for those images. It is designed to be stateless on the service side, so you can grow it without tying identity to one box. Inside a registry, repositories hold multiple tagged versions of an image. Clients push images up and pull them down. Keep the distinction clean. The image is the blueprint. The registry is the organized place that stores and ships those blueprints. The default public cloud registry most people meet first is Docker Hub. You search, you download, you publish. Private work usually needs a login first, because authentication is what keeps private repositories and pipeline operations from being open to the world. Do not confuse three nested words. The image is the packaged snapshot. A repository groups related images under one name. A registry is the service that hosts many repositories. Tags sit on top of a repository and name versions. So you might have one repository called express-app, and inside it, two tags, latest and 0.0.1. Same family, different labels. That chain is the whole mental model. Image, then repository, then registry, then container when someone finally runs a tag. If you remember only one picture, remember that tags are how you track, roll back, and tell a teammate which exact snapshot to pull. There are two everyday paths from nothing to a running container. Path 1. Pull an existing image from a registry, then run it. Path 2. Write a Docker file, build a local image, then run that. The first path is how you consume someone else's work. The second is how you produce your own. Both end at a container. Both, if you want anyone else to use the result, eventually go back through a registry. Watch the arrows: registry to image via pull, image to container via run, or Docker file to image via build, image to container via run, then image back to a registry via push. Same destination, different starting door. Authentication is not a paperwork afterthought. In Docker Hub and in private registries, login exists so pushing and pulling stay under control, especially for private repositories and DevOps pipelines. Without it, anyone who can reach the endpoint can overwrite what your cluster is about to run. Public official images can often be pulled anonymously. Private company images cannot. The login step is the lock on the warehouse door. You will see Docker login later in the Express walkthrough. Remember why it is there. Not because the command is fashionable, but because a registry that stores production blueprints has to know who is allowed to write them. Registries come in two big families. Cloud-hosted public registries are managed services. They are easy to start and they plug into other cloud platforms. Private or self-hosted registries run on your own infrastructure when you want maximum control, security, and speed. Public repositories enable broad access: official images, community images, automated builds, scanning, and collaboration. Private repositories support restricted access, internal distribution, faster continuous integration and delivery, cluster deployment, and storage you actually own. The choice is not fashion. It is about who may see the image, how close the store sits to the machines that run it, and how much operational work you are willing to take on. Name the managed options so they stop being alphabet soup. Docker Hub is the default and largest public registry, with millions of official and community images. Amazon Elastic Container Registry is AWS's managed registry, wired into that cloud. Google Artifact Registry is Google Cloud's recommended store for container images and other artifacts. And yes, the older Google Container Registry is deprecated. Azure Container Registry is Microsoft's service for the Azure platform. GitLab Container Registry lives inside GitLab's CI and CD world, so build, test, and launch can stay in one place. Same job for all of them. Hold images, hand them out, and usually add identity and scanning on top. If you do not want a vendor to host the warehouse, you can run one yourself. Docker ships an official open source image called Registry, tag 2. That image is a basic local registry. You start it, map a port, and you have a push and pull endpoint on your own machine or server. Harbor is the enterprise-shaped sibling. It is also open source, but it adds vulnerability scanning, role-based access control, image replication, and policy-based retention. You can deploy Harbor on-premises or in the cloud, and it talks to Kubernetes and Docker. Rule of thumb: Registry 2 is the teaching lab and the simple cache. Harbor is what you reach for when security teams start asking who can pull what. Here is how you start a basic local registry. The command is docker run, detached, publish port 5000 to 5000, always restart, name the container registry, and use the image registry:2. In plain words, start the official registry image in the background, expose it on localhost port 5000, give it a stable name, and if it dies, bring it back. That port is the local endpoint you will put in every later tag. The first time you run it, Docker may need to pull registry:2 itself from the public library. After that, you have a warehouse on your own machine. Next, you need something to put in that warehouse. Pull a well-known public image. Docker pull Ubuntu:latest. That talks to the public library, not to your local registry yet. You will see layers download or a note that they already exist, plus a digest. The digest is a content fingerprint. The tag latest is just a moving label. After this command, Ubuntu:latest sits on your machine, ready to be retagged toward localhost: 5000. You have not published anything of your own. You have borrowed a public blueprint so you can practice the push path. Tagging is the address label. The command is docker image tag Ubuntu:latest, then localhost: 5000/gfg-image. You are not copying the file system twice. You are giving the same image a second name that points at your local registry. Localhost: 5000 is the endpoint. gfg-image is the repository name inside that registry. If you skip this step and try to push Ubuntu:latest, Docker still thinks the destination is the public hub. The tag is how you say, this snapshot belongs over there. Run Docker images afterward, and you should see both Ubuntu and localhost: 5000/gfg-image sharing an image ID. Now push Docker push localhost: 5000/gfg-image. Docker uses the default tag latest unless you specified another. The client talks to the registry on port 5000 and uploads layers and a manifest. A successful push prints a digest. That digest is what the registry stored. From this moment, any client that can reach that endpoint can ask for the same repository name and get the same content. This is the first time the image has left your local image cache and entered the warehouse. If the push fails, check that the registry container is still running and that the tag really includes localhost: 5000. Prove the round trip. Docker pull localhost: 5000/gfg-image. Docker again assumes latest if you omit a tag. It should report that it is pulling from gfg-image, show the same digest you saw on push, and often say the image is already up to date if you never deleted the local copy. That last line is not a failure. It means the registry and your cache agree. If you want a stricter test, remove the local tagged image first, then pull again. The point of this fifth command is simple. What you pushed is what you can get back. The local registry is no longer a theory. Stopping the lab has two very different endings. Docker container stop registry only stops the process. The named container and typically its data can come back when you start it again. The stronger line is stop, then Docker container rm-v registry. That removes the container and the associated volume. The images you pushed can disappear with it. Treat the first command as parking the warehouse. Treat the second as demolishing it. In a teaching session, demolition is fine. On a shared server, it is how people lose every tag build they thought was safe. Know which one you are typing before you press enter. Zoom out to the working model. On one side is the Docker client. It authenticates, then it pushes and pulls. In the middle is the registry service, metadata, layers, tags, and often a cache so repeated pulls are cheap. Behind that is durable storage, disks or object storage that actually keep the blobs. Authentication sits on the client to registry arrow. Tags live in the registry's index. Layers are the bulky content. Permissions decide who may write at a repository and who may only read. Once you see those four pieces, client, registry logic, storage, and access control, every cloud product in the earlier list is just a hosted version of the same diagram. Why bother with a private registry at all if public hubs exist? Because internal images carry your source layout, your secrets if you were careless, and your release cadence. Private repositories give restricted access, keep distribution inside the company network, speed up continuous integration, feed clusters without leaving your region, and let you control how long blobs live. Public official images are still the right place to start a from line. Your own application images usually should not be world readable. The registry type follows the sensitivity of the blueprint, not the fashion of the week. Now switch from a borrowed Ubuntu image to an app you built. The public-repository walkthrough starts with an account on the hosted hub, then optionally a named repository. Next, you generate a small Express application, a Node web server that listens on a port. That app is just files on disk until you write a Docker file. The Docker file is the recipe that turns those files into a portable image. The username you chose becomes the first half of the image name, like rhythmshandlya/express-app. That naming is not decoration. The hub uses it as the repository path when you log in and push. Walk the Docker file line by line because every instruction becomes a layer. From node:16 starts from an official node image. Workdir sets /usr/src/app as the working directory. You copy package files first, then run npm install so dependency layers can be cached when only app code changes. Then copy ... brings in the rest of the source. Expose 3000 documents the port. CMD in exec form runs npm start. Order matters. Putting install before the full copy is the classic cache trick. Putting it after would rebuild node modules on every tiny edit. The file is short, but it is the entire contract between your laptop and every machine that later pulls the image. Build with Docker build-t rhythmshandlya/express-app, then a space and a dot. The -t names the image. The dot is the build context, this directory. Because you did not write a tag after the name, Docker assigns latest automatically. Then run it locally. Docker run -p3000:3000 rhythmshandlya/express-app. The -p maps host port 3000 to container port 3000, the same port the Docker file exposed. At this point, the app is only on your machine. The image exists. A container is serving. Nobody else can pull it yet because you have not authenticated and you have not pushed.